Tonight, imagine waking up and looking out through a spacecraft window. There is no city below you, no ocean, no continent, no familiar blue curve of Earth, only darkness. And somewhere behind that glass is the planet you were born on, already impossibly far away. At first, that sounds like the beginning of a journey. But there is a problem. A spacecraft can carry people across space. It can recycle water, grow food, produce oxygen, shield its passengers from some of the radiation outside. But eventually, if the journey lasts long enough, something changes. The spacecraft stops being a vehicle. It becomes the place where an entire human society has to live, a closed ecosystem, a home, a world. And that raises a question far more difficult than simply asking how we could build a spaceship large enough to reach another star. How do you build a spaceship that can keep humanity alive long enough to become our new planet? Because crossing interstellar space is not just a problem of distance, it is a problem of generations. Every kilogram must matter. Every drop of water may have to be used again and again. Every crop failure, equipment breakdown, radiation event, medical emergency, and human conflict could become something the crew cannot simply escape from. And if the destination is thousands of years away, the people who finally arrive may have never seen Earth at all. If you enjoy these quiet journeys into the places where real science becomes almost impossible to imagine, consider subscribing. It helps us keep making these slow, detailed documentaries for nights when you want to disappear into the universe for a while. Because by the end of tonight, we are going to follow this idea all the way from the first fragile spacecraft humans have actually built to the enormous engineering problem of creating an artificial world capable of carrying generations across the darkness between stars. We will look at what physics allows, what biology demands, what history has already taught us about living inside sealed environments, and why the hardest part of the journey may have nothing to do with the engines. The destination is not simply another planet. The destination is survival itself. Now, let's begin. There is a strange moment that happens whenever we imagine leaving Earth. We picture the launch, the fire, the enormous machine climbing through the atmosphere, becoming smaller against the blue sky, until, eventually, the planet itself appears beneath it. From orbit, Earth looks almost impossibly fragile. A thin atmosphere, a thin layer of blue, clouds moving over continents and oceans. Everything humanity has ever built compressed into one small world beneath a spacecraft window. And then we imagine going farther. The Moon, Mars, perhaps one day the outer planets. But eventually, if humanity continues pushing outward, there is a distance where the ordinary idea of a spacecraft begins to break down. Because a spacecraft is supposed to take you somewhere. It has a departure point, a destination, a journey measured in hours, days, or perhaps months. But what happens when the journey lasts longer than a human lifetime? What happens when the destination is so far away that the people who launch the ship will never see it? At that point, calling the object a spaceship becomes almost misleading. It is no longer simply carrying passengers. It is carrying an entire civilization. And that civilization would have to survive inside a machine moving through one of the most hostile environments imaginable. Interstellar space. The darkness between stars looks empty. It is not. There is radiation, microscopic particles moving at tremendous speeds, extremely low temperatures, no breathable atmosphere, no natural supply of food or water, no emergency landing, no nearby rescue team. And perhaps the most unsettling part is the distance itself. The nearest star system to the Sun, Alpha Centauri, is more than 4 light-years away. That number is difficult to feel. A light-year is not a measurement of time. It is a measurement of distance. The distance light travels in 1 year, and light moves faster than anything we know how to accelerate a spacecraft to. So even the nearest neighboring star is separated from us by a distance light itself needs more than 4 years to cross. Our current spacecraft are nowhere close to making that trip in a humanly convenient amount of time. Voyager 1, one of the fastest objects humans have sent onto an escape trajectory from the solar system, moves outward at roughly 17 kilometers per second relative to the Sun. That sounds fast. It is not fast on an interstellar scale. At that speed, reaching Alpha Centauri would take tens of thousands of years. Not decades, not centuries, millennia. Imagine launching a spacecraft today. A child is born aboard it. That child grows old. Their children are born. Then their grandchildren. Then their grandchildren's grandchildren. Generation after generation watches the stars through the same windows. The original Earth disappears from living memory, and the ship continues. This is where the idea of a generation ship becomes so strange. The spacecraft would not simply need an engine, it would need a society. It would need farms, hospitals, factories, water treatment, power systems, schools, workshops, storage, computers, spare parts, and enough knowledge to repair systems that may have been designed hundreds of years before the people using them were born. A conventional spacecraft can depend on Earth. Mission control can send instructions. Supplies can be launched. Engineers can build replacement components. A crew member can become sick and, under some circumstances, return home. A generation ship has none of those options. Once it leaves, Earth becomes irrelevant to the immediate survival of the people on board. That is the first great transformation. The ship must become independent. And independence in space is extraordinarily expensive. Consider something as ordinary as air. On Earth, we barely think about it. You breathe in, you breathe out. The atmosphere is simply there. But inside a spacecraft, every breath becomes part of a carefully controlled chemical cycle. Your body consumes oxygen and produces carbon dioxide. Plants can absorb carbon dioxide and release oxygen, but plants also need water, nutrients, light, space, and stable conditions. Mechanical systems can remove carbon dioxide. Other systems can generate oxygen, but every system introduces another dependency. A pump fails, a sensor becomes inaccurate, a filter becomes clogged, a seal deteriorates, a pipe develops a leak. On Earth, many of these problems are inconvenient. Inside a closed spacecraft, they can become existential. The same is true of water. On Earth, water moves through an enormous planetary cycle. Rain falls, rivers flow, oceans evaporate, clouds form, groundwater collects. The cycle continues. Inside a generation ship, there is no planet outside doing that work. The ship has to imitate the cycle. Water used for drinking eventually becomes wastewater. Wastewater must be treated. Water vapor must be recovered from the air. Moisture released by human bodies and plants must be captured. The recovered water must be purified. Then it must return to the system, again and again and again. A successful generation ship would not operate like a cruise liner carrying enough supplies for a long voyage. It would operate more like an artificial ecosystem. And ecosystems are complicated because nothing exists in isolation. Food production depends on water. Water systems depend on energy. Energy systems depend on machinery. Machinery depends on materials. Materials depend on mining or manufacturing. Manufacturing depends on raw resources, and all of it depends on people. People are the strange variable in the system. They can repair machines, but they can also break them. They can grow food, but they can also destroy crops through mistakes. They can cooperate. They can disagree. They can panic. They can become sick. They can have children, and those children will inherit a world they never chose. That last part may be one of the hardest questions of all. The first generation would understand why they are there. They would remember Earth. They would remember oceans, trees, rain, gravity, open skies, the smell of soil after a storm. They would know that their journey had a purpose. Their children might understand it intellectually, but their grandchildren would be different. For them, the ship would not be a temporary home. It would be home. The corridors would be their streets. The agricultural compartments would be their fields. The artificial lighting would define their day. The hum of ventilation systems would be as ordinary as wind is to us. Earth would become a story, then a historical fact, then perhaps something almost mythical, a distant blue world their ancestors once lived on. This is why building a generation ship is not simply an engineering problem. It is a continuity problem. The ship has to preserve not just human bodies, but human knowledge. A technical manual might explain how to repair an engine. But what happens when the engine design becomes obsolete? What happens when a particular material can no longer be manufactured? What happens when the original factory equipment breaks? A truly independent civilization cannot simply carry spare parts forever. It has to carry the ability to make spare parts. And then it has to carry the ability to repair the machines that make those parts. That creates a chain of dependency that quickly becomes enormous. Modern civilization works because millions of specialized systems support one another. A semiconductor factory depends on specialized chemicals. Those chemicals depend on industrial plants. Those plants depend on mining. Mining depends on heavy machinery. Heavy machinery depends on electronics, metals, fuel, lubricants, and countless other components. A generation ship would need to compress some version of that industrial complexity into a closed environment. Not necessarily everything Earth has, but enough to keep the ship functioning for generations. That means the ship would need workshops, machine tools, metalworking capabilities, electrical manufacturing, chemical processing, medical facilities, agricultural equipment, textiles, construction materials, and systems capable of producing replacements when the original components are gone. Because there is one rule that becomes increasingly important the farther the ship travels. Nothing can be assumed to last forever. The spacecraft itself would age, its engines would age, its electronics would age, its structure would experience stress, its seals would deteriorate, its storage systems would degrade. Even the knowledge of how everything works could disappear if it is not deliberately preserved, and that introduces an unsettling possibility. The greatest threat to a generation ship might not be the vacuum outside, it might be time. We often think of engineering in terms of whether something can survive an extreme event. Can a spacecraft survive launch? Can it survive radiation? Can it survive a collision? Can it survive the cold? But a generation ship has to answer a different question. Can it survive ordinary life for hundreds or thousands of years? That is much harder. A bridge on Earth can be inspected, a power plant can be supplied, a city can import food from somewhere else. A ship crossing an ocean can turn around. A generation ship cannot. Once it is far enough from Earth, every problem becomes local. There is no outside. That changes the meaning of reliability. A system that is 99.9% reliable might sound excellent, but over a very long period, failures accumulate. If thousands of components operate continuously for centuries, some of them will fail. So the ship cannot simply be reliable. It must be redundant. There must be backups, and backups for the backups. There must be ways to isolate damaged sections, ways to survive fires, ways to contain depressurization, ways to shut down contaminated areas, ways to preserve seeds, ways to maintain genetic diversity, ways to treat injuries, ways to survive unexpected disasters. In other words, the ship must assume that something will go wrong, because something will. The challenge is not creating a world where nothing fails. The challenge is creating a world where failure does not become extinction. And there is another problem waiting beyond engineering: gravity. On Earth, gravity is everywhere. Our bones grow under it. Our muscles work against it. Our cardiovascular system evolved under it. Our sense of balance depends on it. But inside a spacecraft, without acceleration or rotation, humans experience microgravity. Long-duration spaceflight has shown us that the human body changes in microgravity. Bones lose mineral density, muscles weaken, fluids shift toward the upper body. The cardiovascular system adapts. Vision can be affected. The longer the exposure, the more important these effects become. The International Space Station has given humanity invaluable experience with living in space. But the station is not a generation ship. Its astronauts spend months in orbit, sometimes around a year, and they remain connected to Earth. Supplies arrive, crew members rotate. Medical expertise remains only a communication link away. The station is an outpost. A generation ship would need to be a world. One proposed solution is artificial gravity through rotation. Imagine living inside a huge rotating structure. The floor curves around the inside. As the structure rotates, objects are pushed outward toward the outer wall. That can create an effect that feels similar to gravity. The faster the structure rotates, and the larger its radius, the stronger and more comfortable the artificial gravity can be. But again, scale becomes the enemy. A small rotating habitat can produce artificial gravity, but rotation can also create motion effects that humans find uncomfortable. The larger the structure, the more slowly it can rotate while producing useful artificial gravity. So the ship begins to grow and grow. More habitat volume means more mass. More mass means more energy. More energy means larger power systems. Larger power systems require more cooling. More cooling requires more radiators. More radiators require more structure. Every solution creates another problem. This is the pattern that keeps appearing. A generation ship is not one giant machine. It is a web of interlocking systems. Change one part and something else changes with it. Make the habitat larger and the structural demands increase. Increase food production and energy demand rises. Increase population and resource consumption rises. Add redundancy and mass increases. Add shielding and the spacecraft becomes heavier. Add more people to spread the workload, and the ship needs more food, water, living space, and medical resources. There is no simple answer, only trade-offs, and yet the idea refuses to disappear, because there is a reason humans keep imagining these enormous ships. The stars are there. We can see them every clear night. They are not hypothetical places. They are physical suns scattered throughout the galaxy, and many of them have planets. Thousands of exoplanets have already been confirmed. Some orbit within regions where temperatures could, under the right atmospheric conditions, allow liquid water. Others are nothing like Earth. Some are scorched, some are frozen. Some orbit so close to their stars that their atmospheres may be radically altered. We do not yet know whether any nearby world could truly support human life without enormous intervention. But we do know something important. The galaxy contains an extraordinary number of places to go. The difficulty is reaching them, and that brings us back to the ship. Because before humanity can ask whether another planet could become home, we have to answer a more uncomfortable question. What happens during the journey? If the journey takes decades, we need a spacecraft. If it takes centuries, we need a habitat. If it takes thousands of years, we need something much stranger. We need a world that happens to be moving through space, a world with no sunrise except the one created by lamps. No natural rain, no wild forests, no ocean horizon, no external ecosystem. A world whose atmosphere is contained by walls. A world where every tree, every crop, every breath, and every human heartbeat exists inside a machine. And perhaps the most important question is not whether we could build such a place. It is whether such a place could remain human. Because once the first generation disappears, the mission becomes something different. The people on board would no longer be passengers. They would be the ancestors of everyone who comes next. And the spaceship would no longer belong to the engineers who designed it. It would belong to the children who were born inside it. The ship would become their Earth, and for that to happen, it would need to do far more than survive the journey. It would need to survive us. There is a difference between keeping people alive and giving them a place to live. A submarine can keep a crew alive beneath an ocean. A spacecraft can keep astronauts alive above Earth. But neither one is a complete world. They depend on a larger system. The submarine eventually returns to port. The spacecraft eventually returns to Earth or receives supplies from it. A generation ship has no such relationship. Its supply line is itself. Its port is a destination that may not exist in the form its passengers expect, and its emergency plan cannot simply be, go home. That single fact changes almost every calculation. Imagine a spacecraft leaving Earth with enough food for 50 years. That sounds enormous. But if the trip takes 500 years, it is almost meaningless. The ship would need to produce food continuously, not occasionally, not as an experiment, every day, every year, every generation. The agricultural system would become one of the most important pieces of infrastructure on board. And growing food in space is not simply a matter of putting plants under artificial lights. Plants need light, water, nutrients, carbon dioxide, oxygen, temperature control, and physical space. They also need pollination for many crops. They need protection from pests and disease. And they need genetic diversity if the agricultural system is expected to remain productive over very long periods. On Earth, agriculture has something a spacecraft does not: scale. If one field fails, another may survive. If a particular crop develops a disease, farmers can plant something else. If a region suffers drought, food can sometimes be transported from another region. A closed ship has fewer options. A disease spreading through one crop could become a major crisis. That means the agricultural system would have to be diversified. Different crops, different growing environments, different genetic lines, perhaps separate compartments that can be isolated from one another. The goal would not be maximum efficiency, it would be resilience. And resilience often requires redundancy. That principle appears again and again. The ship cannot have one farm. It needs multiple food systems. It cannot have one oxygen system. It needs alternatives. It cannot have one source of electrical power. It needs backups. The ship cannot depend on a single generation of knowledge. It must teach the next generation how to maintain the world they inherited. That may sound obvious, but education becomes different when your entire civilization is trapped inside one machine. On Earth, a child can grow up without knowing how an electrical grid works. They can become a teacher, musician, artist, doctor, athlete, or farmer without understanding semiconductor manufacturing. A generation ship cannot afford unlimited specialization. There may be room for specialists, but everyone would live inside a system where technical knowledge has survival value. Someone would need to know how the power systems work. Someone would need to understand agriculture. Someone would need medical training. Someone would need mechanical skills. Someone would need to repair electronics. Someone would need to maintain water treatment. And the ship would need to preserve knowledge even when experts die. That means education would not simply be cultural. It would be infrastructure. A textbook could be as important as a water tank. A technical archive could be as valuable as a food store. A forgotten procedure could become a dangerous gap in the civilization's ability to survive. Imagine a repair technique known by only 3 people. Then an accident happens. 2 die. The third becomes seriously ill. Suddenly, knowledge that existed for generations is concentrated in one human mind. This is why redundancy must apply to knowledge too. The ship would need people who can teach, and people who can learn. Again and again, the civilization on board would have to reproduce not only biologically, but intellectually. Every generation would need to inherit enough understanding to keep the system alive. This introduces another strange feature of the generation ship. Its true cargo is not machinery, it is continuity. The ship must preserve a chain stretching from Earth to the destination. And that chain can break in many ways. A technical collapse can break it. A biological disaster can break it. A demographic crisis can break it. A social conflict can break it. Even cultural change can break it. Suppose the original mission requires the population to maintain a particular agricultural system. 200 years later, the descendants decide that system is unnecessary. They replace it. The replacement works, for a while. Then something goes wrong. The old knowledge still exists in an archive, but nobody remembers how to use it. The information is technically preserved. Functionally, it is lost. That is an important distinction. Civilizations do not survive simply because information exists. They survive because people know what the information means and how to apply it. The ship would therefore need a living culture of maintenance. Repair would have to be normal. Inspection would have to be normal. Teaching would have to be normal. Preparing for failure would have to be normal. A society raised under those conditions might develop a very different attitude toward resources. On Earth, wasting a small amount of water can feel insignificant because the planet contains an enormous amount of it. Inside the ship, waste would be visible. Every liter matters. Every kilogram of food matters. Every unit of energy matters. The walls themselves matter. A damaged section of habitat cannot simply be demolished and replaced with materials imported from somewhere else. Materials have to come from somewhere on board. That raises one of the most difficult engineering questions. Where do the raw materials come from? The ship could carry a large reserve of metals, polymers, glass, ceramics, and other materials. But the longer the journey, the more valuable recycling becomes. A civilization that throws away useful material would slowly consume its own future. So waste would have to be treated differently. Metal could be recovered, water could be purified, organic waste could be processed. Some materials could be broken down and reused. Even carbon becomes valuable because it can move between living organisms, air, water, and manufactured materials. In a sense, the ship would need to behave like a miniature planet. Earth is incredibly good at recycling matter. Atoms move through enormous cycles. Carbon moves through the atmosphere, oceans, rocks, plants, animals, and microorganisms. Nitrogen moves through air, soil, organisms, and water. Water moves between oceans, atmosphere, land, ice, and living systems. A generation ship would have to create simplified versions of these cycles. But there is a major difference. Earth has billions of years of evolutionary history behind its ecosystems. A spacecraft would have to deliberately construct its own, and that is dangerous, because ecosystems are not machines with perfectly predictable outputs. They are networks of living things. Introduce a new organism and it may interact with others in unexpected ways. Change the nutrient balance and one species may become dominant. Alter temperature or humidity and a disease may spread. A closed ecosystem can become unstable. This is one reason why experiments with closed ecological systems have been so difficult. Humans have already tried creating miniature artificial worlds. One of the most famous examples was Biosphere 2, built in Arizona in the early 1990s. It was a sealed experimental environment containing different ecological zones. Researchers attempted to live inside it while monitoring the atmosphere, water, agriculture, and biological systems. The experiment revealed just how difficult it is to reproduce Earth's complexity in a controlled environment. Oxygen levels fell. Carbon dioxide fluctuated. Unexpected ecological interactions occurred. The project was not a failure in the sense of being useless. Quite the opposite. It demonstrated something extremely valuable. A closed ecosystem can behave in ways its designers did not fully anticipate. That lesson matters enormously for a generation ship, because a generation ship cannot afford to discover a fundamental ecological problem after departure. There is no convenient way to open the roof, no ocean to draw water from, no external atmosphere to balance the gases, no neighboring farm, no wild ecosystem waiting outside the hatch. Everything is connected, and the larger the system becomes, the harder it may be to understand completely. This is where the idea of becoming a planet takes on a deeper meaning. A planet is not just a rock in space. It is a network of interacting systems: atmosphere, water, geology, biology, energy, climate, chemistry. A spacecraft designed for thousands of years would have to imitate enough of those functions to become self-sustaining. But it would still be fundamentally different. Earth can absorb enormous disturbances because it is enormous. The atmosphere has mass, the oceans have thermal inertia, the crust stores carbon. Life exists in countless overlapping ecosystems. a ship would be tiny by comparison. One major failure could affect the entire habitat. This is why shielding becomes so important. Outside Earth's atmosphere and magnetic field, radiation becomes a serious problem. The sun constantly releases energetic particles. Beyond the protection of Earth's magnetic environment, astronauts are exposed to a harsher radiation environment. There are also galactic cosmic rays, extremely energetic particles originating from outside the solar system. A generation ship would need protection against them. One obvious solution is mass. Material between the crew and the radiation can reduce exposure. Water is useful. Food stores can be useful. Hydrogen-rich materials can be useful. Even the structure of the habitat itself can contribute. But again, mass creates another problem. If the ship must carry enormous quantities of shielding, launching all of that material from Earth becomes extraordinarily difficult. This is one reason concepts for very large spacecraft sometimes involve using resources from space, rather than lifting everything from Earth's surface. Asteroids contain metals. The Moon contains useful materials. Space-based construction could eventually change the economics of large habitats. But that would require an industrial civilization already operating beyond Earth. And suddenly the generation ship is no longer the first step. It becomes part of a much larger chain. Before humanity can build enormous interstellar habitats, it may need a mature space economy. Mining, manufacturing, power generation, construction, robotics, transportation, large-scale orbital infrastructure. The first interstellar ship may therefore be the final product of centuries of development, not a single invention, a civilization-wide project. And there is another challenge that is easy to underestimate: energy. Moving a large spacecraft to another star requires an enormous amount of energy. The exact amount depends on the mass of the ship and the velocity it needs to reach, and velocity is brutally expensive. As a spacecraft becomes faster, the energy required rises dramatically. For an interstellar mission, even a small fraction of the speed of light represents tremendous kinetic energy. At 10% of light speed, a spacecraft is moving at about 30,000 kilometers per second. That is far beyond the speeds of today's crewed spacecraft. And if the ship is enormous, the energy requirement becomes enormous too. This is where the dream of a planet-sized spacecraft collides with the physics of propulsion. The bigger the habitat, the more people it can support. The more people it supports, the more resilient the population may become. But the bigger the ship, the harder it is to accelerate. A larger ship also needs more shielding. More shielding means more mass. More mass means more energy. So the design becomes a balance between survivability and acceleration. Too small, and the population may be vulnerable. Too large, and the propulsion problem becomes overwhelming. This is not simply a matter of building a bigger engine. It is a matter of moving an enormous quantity of matter across interstellar space. Several propulsion concepts have been proposed over the decades: nuclear propulsion, fusion propulsion, beamed propulsion, solar sails, antimatter propulsion in theoretical studies. Each comes with enormous technical challenges. Some are physically plausible but far beyond current engineering capabilities. Others depend on technologies that do not yet exist at the necessary scale. The important point is that physics does not provide an easy shortcut. There is no known engine that lets a massive spacecraft simply jump across the galaxy. No warp drive has been demonstrated. No wormhole has been observed being used as a transportation system. For a serious generation ship, we are forced back toward the technologies physics actually permits. And that makes the mission slower, perhaps much slower. But speed is not the only way to solve distance. Time can become part of the spacecraft's design. If humans cannot travel quickly enough, perhaps their civilization can travel slowly. That is the radical idea behind the generation ship. The passengers do not need to survive until arrival as individuals. The civilization does, the ship does, the genetic line does, the knowledge does, the mission does. And once you think about the mission that way, the concept becomes almost unsettlingly logical. We already build structures meant to last longer than one human lifetime. We preserve knowledge across centuries. We construct cities that outlive their founders. We send probes that continue operating after their creators are gone. A generation ship would extend that idea to its ultimate limit. It would be a machine designed to outlive everyone who built it. Its original crew would be temporary. Its descendants would be the real passengers. And perhaps the first people to step onto another star's planet would look back at the ship that carried them and realize something strange. The spacecraft was never really their vehicle, it was their ancestor, a manufactured world passed down from generation to generation, a moving piece of Earth, a memory of a planet that had once seemed infinite. But before that future can exist, there is one problem we have not fully confronted: the people themselves. Because machines can be repaired, crops can be replanted, water can be filtered, but human beings carry something much harder to engineer. They carry memory, they carry fear, they carry ambition, they fall in love, they argue, they create traditions, they reject the plans of previous generations, and eventually, they may ask the most dangerous question a generation ship can face: why are we still following the mission? If Earth has become a legend, why should the destination still matter? If nobody alive remembers the original launch, what makes the original promise binding? The answer cannot simply be written into a computer. It has to survive inside human beings. And that may be the true beginning of the generation ship story. Not the engines, not the farms, not the radiation shielding, the people. Because once the first child is born on board, the mission changes forever. That child did not volunteer. They did not sign the launch documents. They did not see Earth from orbit. They did not watch the spacecraft leave. They simply opened their eyes one day inside a metal world and discovered that this was home. And from that moment forward, the ship would no longer be carrying a crew. It would be raising a civilization. The first child born aboard a generation ship would experience something no human being has ever experienced before. They would be born between worlds, not on Earth, not on another planet, but inside a manufactured environment moving through interstellar darkness. Their first sky would be a ceiling. Their first horizon would be a corridor. Their first rain might be artificial. Their first forest might exist inside an agricultural chamber, beneath carefully controlled lights. And the stars outside the windows would be beautiful, but they would also be unreachable. That distinction matters. To us, seeing another star creates a feeling of possibility. To someone born aboard the ship, a star might simply be scenery. The ship would be their entire physical reality. That means the psychological design of the habitat could be just as important as its mechanical design. A place can keep you alive without making you want to stay alive. Earth gives human beings enormous psychological variety. Open landscapes, crowded cities, quiet forests, mountains, oceans, weather, sunrise, seasons. The ability to walk outside without thinking about pressure seals or oxygen reserves. A generation ship would have to recreate at least some of that variety, not because people need luxury, because people need environments that feel alive. Imagine living for your entire life inside a narrow industrial spacecraft. Even if the air is clean and the temperature is perfect, the psychological burden could become enormous. There would be no true wilderness, no place where the machinery stops, no horizon extending for hundreds of kilometers. Every wall would eventually remind you that you are enclosed. This is one reason some concepts for large habitats use rotating structures with enormous interior spaces. Instead of thinking of the ship as a collection of rooms, engineers could think of it as a miniature landscape. Fields, trees, water reservoirs, residential areas, workshops, recreation spaces, artificial day and night, perhaps even weather-like systems. The goal would be to make the habitat feel less like a spacecraft and more like a world. But scale is expensive. Every additional cubic meter requires structure. Every structure requires materials. Every habitat volume needs energy, maintenance, and environmental control. A truly planet-like interior could become enormous. And there is a point where the ship becomes so large that calling it a spaceship almost feels absurd. It becomes an artificial world with engines attached. That is the direction the idea naturally leads. The destination determines the design. If the destination is Mars, you can imagine a spacecraft delivering people to a planet that already provides gravity, atmosphere, and natural resources. If the destination is another star, the ship may have to provide almost all of those things for the entire journey. The ship itself becomes the planet. But planets have another advantage. They are old. They have had millions or billions of years for their systems to settle into equilibrium. A ship would begin its journey as an engineered experiment. Everything would have to work from the beginning. And there would be no time to wait for evolution to fix mistakes. That makes testing crucial. Before such a ship could leave Earth, humanity would need to learn how to operate closed ecosystems for extremely long periods. Not months, not years, potentially decades, perhaps generations. We would need to understand how microbial communities change, how agricultural systems evolve, how materials age in closed environments, how people psychologically respond to permanent confinement, how governance changes when resources are finite, how children develop when they grow up without natural environments. These questions are not purely futuristic. Some pieces are already being studied. The International Space Station has taught us about long-duration human habitation. Closed environment experiments have taught us about ecological complexity. Antarctic research stations provide limited insight into isolation and confinement. Submarines demonstrate how crews function inside sealed environments. But none of these experiences perfectly reproduce a generation ship, because a generation ship would combine all of them: isolation, confinement, resource dependence, permanent settlement, artificial ecology, long-term maintenance, intergenerational society, and the absence of an escape route. That last factor may be psychologically enormous. A person living on a remote research station knows that eventually they can leave. An astronaut knows that a mission has an end. Even a prisoner knows that the world exists beyond the walls. A generation ship might contain people who know that there is no outside world available to them. Their descendants could inherit that reality without ever having experienced anything else. That could shape the culture in ways we cannot confidently predict. Perhaps the society would become deeply cooperative, or perhaps it would become intensely controlled. Who decides how many children can be born? How much food should be allocated? What happens when population rises beyond the habitat's safe capacity? Who gets access to scarce medical resources? Who decides which technologies are worth maintaining? What happens if a group believes the ship should change course? These are not abstract philosophical questions. They are engineering questions because social instability can damage physical systems. A disagreement over power allocation can become a power failure. A conflict over food can become a food crisis. A political struggle can interrupt maintenance. A generation ship would therefore need governance. And governance would have to survive longer than any individual government on Earth. That is a remarkable requirement. Political systems change. Countries rise and fall. Laws are rewritten. Cultures evolve. A spacecraft launched with one constitution might arrive centuries later with a society almost unrecognizable to the people who wrote it. Trying to prevent that change might be impossible, and perhaps undesirable. A civilization that cannot change may become brittle. The ship needs continuity, but it also needs adaptation. That is another balancing act. Too much change, and the original mission could disappear. Too little change, and the society could become unable to respond to new conditions. In a sense, the ship would need its own evolutionary process. Not biological evolution alone, cultural evolution, technological evolution, institutional evolution. The spacecraft would need to change while remaining recognizable. That sounds familiar because it is exactly what civilizations on Earth do. Cities are rebuilt, languages evolve, technologies change. Old traditions disappear, new ones emerge, yet people still understand themselves as belonging to a continuous civilization. A generation ship would have to create that same sense of continuity inside a moving machine. And there is an even deeper biological question. Population. How many people would need to live aboard? There is no universally accepted single number because the answer depends on assumptions about genetics, demographics, technology, reproductive strategies, and mission duration. A larger population provides greater genetic diversity and a larger pool of skills, but every additional person requires food, water, living space, medical care, and energy. A smaller population reduces resource demand, but it increases vulnerability to demographic problems and loss of specialized knowledge. So the population would need to be large enough to remain healthy and resilient, but small enough for the habitat to support. That becomes a balancing problem measured over centuries. Birth rates matter, death rates matter, age distribution matters. The ship cannot suddenly discover that almost everyone is elderly, nor can it allow population growth to exceed the habitat's capacity. The population would have to be actively managed, and that creates ethical questions that have no simple technological solution. Who decides? What rights would people have? Would reproductive choices be completely individual? Would the ship impose limits? Could future generations refuse the mission? These questions become especially uncomfortable when you remember that the people making the decisions are creating conditions for humans who do not yet exist. The original crew might believe the destination is worth the sacrifice, but their descendants might disagree, and they would have legitimate reasons. A person born 300 years into the voyage could reasonably say, "I did not choose this. Why should I continue?" The answer cannot be, "Because your ancestors promised." That might not be enough. So perhaps the mission would need to become culturally meaningful. The destination would need to remain more than coordinates. It would need to become a shared story. Children would learn about Earth. They would see images of oceans and forests. They might study the history of the launch. They might celebrate the anniversary of departure. They might maintain rituals connected to the planet their ancestors left. Earth could become part of the ship's mythology, not fictional mythology, historical memory. And this creates an unusual emotional paradox. The farther the ship travels, the more important Earth may become psychologically. The planet would become physically less relevant while becoming emotionally more important. A person might never have stood on Earth, yet Earth could be the central symbol of their culture, the origin, the lost home, the place where the journey began, and eventually the ship might become the only physical connection remaining. There would be objects on board from Earth, seeds, books, photographs, scientific instruments, artifacts, perhaps soil, a small amount of material from the original planet carried across the darkness. Imagine a child centuries later holding a handful of soil from Earth. To us, soil is ordinary. To them, it could be almost sacred. It would contain something their entire civilization came from, but could never visit. The ship would therefore carry two things simultaneously, a future and a memory. That is why the phrase, "new planet," is more accurate than it first appears. The ship would not literally become a planet. It would not have a natural atmosphere extending thousands of kilometers. It would not have oceans or geological cycles like Earth. But for the people living inside it, functionally it could occupy the same role. It would provide air, water, food, shelter, gravity, energy, social space, a place to raise children, a place to die, a place to remember, a place to call home. And that last function may be the most difficult to engineer. Because home is not simply a collection of physical systems. Home is familiarity, continuity, belonging. The generation ship would have to create those things deliberately. Perhaps every person would know the layout of the habitat. Perhaps neighborhoods would develop their own identities. Children would play in the same parks their parents played in. Trees would grow old. Buildings would be repaired instead of replaced. Certain places might become historical landmarks, a corridor where the first child was born, a garden planted by the original crew, a room containing the first telescope used to observe the destination star. Over centuries, the ship could accumulate history. The machine would stop feeling new. It would become ancient. That is a strange thought. The spacecraft would begin as humanity's most advanced technological achievement. But after 500 years, it might be an old world. Its walls could carry generations of repairs. Its equipment could contain components older than the people using them. Its systems might be modified so many times that the original design would barely resemble the functioning habitat. This is how technology becomes civilization. A city is not just the buildings originally constructed. It is everything that has been added, repaired, removed, forgotten, and rebuilt. A generation ship could follow the same path, and that means its engineers would have to design not just for operation, but for modification. The ship must be repairable, but more than that, it must be adaptable. People must be able to improve it. If every component is sealed behind inaccessible structures, future generations may not be able to maintain it. If every system depends on proprietary technology that no longer exists, the ship could slowly become impossible to repair. So simplicity may become more valuable than sophistication. A complicated system may perform beautifully when new. A simpler system may survive better over centuries because people understand it. That is a lesson humans have learned repeatedly. The most advanced technology is not always the most durable. Sometimes the best design is the one that can be repaired with tools that ordinary people understand. A generation ship would need that philosophy everywhere. Its future engineers may not have access to the same manufacturing processes as the original builders. They may not even understand every decision the original engineers made. So the ship would have to leave room for human ingenuity. That means accessible systems, standardized components, modular structures, clear documentation, local manufacturing, and enormous stores of knowledge. The ship would need to teach its descendants how to become engineers of a world they did not build. But even with perfect engineering, there is one threat no design can completely remove: entropy. Everything ages. Everything wears down. Energy becomes less useful when it spreads into less organized forms. Machines require maintenance because the universe does not naturally preserve human-made order. A spacecraft can delay deterioration. It cannot abolish it. That means the ship's real battle is not against one disaster. It is against accumulation. One tiny failure, then another, a worn bearing, a cracked seal, a damaged cable, a degraded battery, a crop disease, a medical problem, a manufacturing shortage, a mistake in training. Each event may be manageable, but over centuries, the number of opportunities for failure becomes enormous. The ship therefore needs something Earth has in abundance. Time, not time to wait, time to repair, time to learn, time to adapt. The civilization on board would need to detect small problems before they become large ones. That might become one of the most important cultural habits. Maintenance would not be an afterthought. It would be a form of survival. A person repairing a water pump might be doing work that seems ordinary, but that pump could be connected to the entire habitat. A person checking a crop could be protecting thousands of future meals. A person teaching a child how to operate a machine could be preserving a skill that will matter a century later. In such a civilization, small actions could have enormous consequences, and that is perhaps the first real sign that the spaceship has become a planet. On Earth, we often forget how interconnected our survival is. The farmer, engineer, electrician, doctor, scientist, teacher, mechanic, and sanitation worker all participate in the same planetary system. A generation ship would make that connection impossible to ignore. Every person would live inside the consequences of everyone else's work. There would be nowhere else to go. No second atmosphere, no second farm, no second civilization. One world, one closed system, one fragile chain, and somewhere ahead, moving silently through the darkness, would be the destination. A star that most people on board had never seen with their own eyes. A place their ancestors had selected before they were born. A world that might become the reason the entire artificial civilization existed. But reaching it would require the ship to survive something even harder than distance. It would have to survive history. because by the time the destination finally grows large enough in the ship's windows, the people on board may be almost completely different from the people who launched it. Different language, different customs, different memories, different dreams. The only thing they might share with the original crew is a continuous line of ancestry, and perhaps that is the true meaning of a generation ship, not transporting humans through space, transporting humanity through time. There is a point in every generation ship's journey when the original mission would begin to feel less like a mission and more like history. The people who launched the vessel would be gone, their children would be gone, their grandchildren might be gone, the destination would still be ahead, and the ship would continue doing what it had been designed to do, moving, protecting, recycling, growing, waiting. That is where the concept becomes something much larger than transportation. A generation ship is a civilization trapped inside a machine, but unlike a civilization on Earth, it has no wilderness waiting beyond its borders. There is no unexplored valley where a group can settle, no new river to follow, no distant continent where dissatisfied people can start again. Every argument happens inside the same walls, every shortage affects the same population, every mistake remains inside the same ecosystem. And that means the ship's internal architecture would matter enormously. A generation ship could not simply be a long metal tube filled with rooms. It would need to be organized around survival. Some areas might be dedicated to agriculture, others to manufacturing, others to energy production, storage, medical care, education, recreation, and habitation. The most critical systems would likely need physical separation. If a fire destroys one agricultural module, another should remain operational. If contamination enters one water processing system, it should be possible to isolate it. If part of the habitat loses pressure, doors should seal automatically. The ship would have to behave almost like a collection of small worlds connected together. That way, one failure would not necessarily become a civilization-wide disaster. This principle already exists in spacecraft engineering: redundancy, isolation, fault tolerance. But on a generation ship, the consequences become far more severe because the mission lasts so much longer. Imagine a spacecraft that has been traveling for 300 years. A component fails, the replacement part exists, but nobody alive remembers where it was stored. The technical archive says it is in Storage Compartment 7. Storage Compartment 7 was redesigned 200 years ago. The replacement was moved. The record was not updated. A simple maintenance problem becomes a search through centuries of accumulated changes. This is why the ship's information system would be as important as its physical infrastructure. It would need a permanent memory, not just digital files. Digital systems themselves can become obsolete. A file format can become unreadable. A storage medium can degrade. A computer architecture can disappear. So long-term knowledge preservation might require multiple forms of redundancy: digital records, physical documentation, training, institutional memory, perhaps even physical demonstrations. The ship's civilization would need to remember how to remember. That sounds philosophical. It is actually engineering, because a machine can only be maintained if someone understands what it is supposed to do. And the ship would not remain unchanged. That is one of the biggest assumptions we have to abandon. No matter how carefully the original engineers design it, future generations will modify it. They will discover better ways to grow food, more efficient energy systems, new medical treatments, better manufacturing techniques. They may replace entire subsystems. They may build new rooms. They may change how the habitat is organized. Eventually, the original spacecraft could become almost unrecognizable. The descendants would not be living inside the ship their ancestors designed. They would be living inside a civilization built upon it. That means the original design has to allow for evolution. The ship must be modular, repairable, expandable where possible. Its systems must have interfaces that future engineers can understand. This is one reason simple standards could become incredibly valuable. If every generation invents completely incompatible systems, maintenance becomes increasingly difficult. But if the ship maintains common standards for electrical power, mechanical connections, data, pressure systems, and manufacturing, new technologies can replace old ones without requiring the entire civilization to rebuild itself. In other words, the ship needs technological succession. Just as biological generations replace one another, technological generations must do the same. And there is a beautiful symmetry here. The original crew would design the ship for their descendants. Those descendants would redesign it for theirs. The machine would evolve alongside the people. Eventually, perhaps nobody would remember what parts were original. The spacecraft would become an artifact assembled by centuries. And this raises another problem. Ownership. Who owns the ship? The original builders? The current population? Everyone who will ever live aboard it? There is no simple legal answer. But there is a practical one. The people living inside it have to feel responsible for it. A generation ship cannot survive if every generation treats the habitat as something inherited rather than something maintained. The culture would have to encourage stewardship. The idea that you are borrowing the world from people who have not yet been born. That concept already exists on Earth, but on a generation ship, it becomes literal. If you damage a system today, your grandchildren might pay for it. If you preserve a forest, your descendants might enjoy it. If you teach a technical skill, someone 200 years from now might survive because of it. The consequences of ordinary decisions stretch across generations. This could create a powerful sense of responsibility, or it could create enormous psychological pressure. Imagine being told from childhood that your society depends on you, that every engineer matters, every doctor matters, every farmer matters, every child matters. There is something noble in that, but there is also danger. People are not machines. They need freedom, rest, creativity, privacy, relationships, meaning. A civilization built entirely around survival could become unbearable. If every decision is measured against efficiency, life could become sterile. The ship might successfully preserve human biology while slowly destroying what makes human life worth preserving. That is why a generation ship would need art, music, stories, games, celebrations, spaces for solitude, spaces for community. People would need reasons to live beyond maintenance. This is where the idea of a new planet becomes especially important. A planet is not just a survival system, it is a place where life unfolds. Earth does not ask us to justify every moment. We can waste an afternoon watching rain. We can walk through a forest without calculating its oxygen output. We can look at the ocean without thinking about how many liters it contains. A generation ship would have to find ways to preserve some of that freedom. Otherwise, the ship could become a prison with excellent life support systems. The psychological difference between a habitat and a home might depend on whether people can experience life as something more than survival. That could mean designing public spaces, gardens, artificial lakes, large open chambers, natural-looking landscapes, places where people can gather, places where people can disappear, and perhaps windows. Real windows are complicated on a spacecraft. Every opening in the hull can create structural and thermal challenges. Large transparent surfaces may be vulnerable to impacts. Radiation protection becomes harder, so perhaps most of the habitat would remain enclosed. But even simulated views could matter. Screens could show Earth, or landscapes, or changing skies. Artificial lighting could reproduce daily cycles. Some habitats might use large illuminated spaces to create the feeling of outdoor environments. The technology would not be the same as standing under the sun, but human perception is powerful. A carefully designed environment could feel surprisingly natural. Still, there is one thing no simulation can perfectly replace: gravity. If a generation ship uses rotation, the artificial gravity would need to be carefully designed. The human body evolved under Earth's gravitational field. A rotating environment can produce a gravity-like acceleration, but it also introduces effects that do not exist on Earth. When a person moves inside a rotating habitat, the apparent direction of forces can change. Walking toward the axis or away from it can feel different. Moving your head quickly can produce sensations caused by the rotation. The larger the radius, the smaller these effects can become for a given artificial gravity level, which again pushes the ship toward larger dimensions. This is a recurring theme. Human comfort demands space. Space demands mass. Mass demands energy. Energy demands infrastructure. Infrastructure demands more mass. The ship becomes a feedback loop. And then there is radiation. A generation ship traveling for centuries cannot simply accept the radiation levels astronauts experience during short missions. Even modest exposure accumulates. The design would therefore likely place the living areas behind substantial shielding. Water tanks could be arranged around occupied spaces. Food storage could serve a dual purpose. Waste material might also be positioned strategically. The ship's protective layers could become part of its architecture. The thickest sections might be where people sleep. Critical systems could be placed deeper inside. Some areas might remain unoccupied specifically because their position makes them useful as shielding. This changes how the ship would look. From outside, it might resemble an enormous engineered structure. But from inside, people might never realize how much material surrounds them. Their homes could sit beneath layers of water, food, equipment, and structural material. The same resources that sustain them could also protect them. And then there is the problem of collisions. Space is often described as empty, but interstellar space contains dust and tiny particles. At high velocity, even very small particles can carry significant kinetic energy. A grain-sized object striking a spacecraft at a substantial fraction of the speed of light would not behave like an ordinary speck of dust. It could become a serious hazard. This means the ship's leading edge would need protection. Engineers have studied concepts such as sacrificial shielding, including Whipple shields, where a thin outer layer breaks incoming particles into fragments before they reach the main pressure hull. For interstellar travel, however, the problem becomes more severe as speed increases. The faster the ship moves, the more energy an impact carries. So again, speed has a price. A slower ship takes longer to reach its destination. A faster ship faces harsher impacts and vastly greater propulsion requirements. There may be no perfect speed, only a compromise between travel time and survivability. And the destination itself creates another problem. If the ship arrives at another star system after centuries, how does it slow down? It is easy to imagine accelerating toward another star. It is harder to imagine arriving there and stopping. A spacecraft traveling at a significant fraction of light speed cannot simply turn off its engine and expect to remain near the destination. It would continue moving. So the mission needs a braking system. Perhaps propulsion is used in reverse. Perhaps the spacecraft uses a magnetic or electric interaction with stellar material. Perhaps a large sail interacts with the destination star's light. Each concept has limitations, and the energy involved can be enormous. For a generation ship, the arrival phase is not an afterthought. The spacecraft has to survive the journey and still have enough capability to enter the destination system safely. Then there is the question of what happens after arrival. Suppose the target planet exists. Suppose it is rocky. Suppose it lies in a potentially habitable orbit. That does not mean humans can simply step outside. The atmosphere might be toxic. The pressure might be wrong. The temperature could be extreme. The surface could contain unfamiliar chemistry. There could be no accessible water. The planet might have an atmosphere that is breathable only in the broadest scientific sense, or not breathable at all. The ship may therefore need to continue functioning after arrival, perhaps for decades, perhaps centuries. The destination would not instantly replace the ship. The ship would still be the safe environment. The people would need to study the planet, build infrastructure, extract resources, create habitats, test the atmosphere, grow crops, establish power systems. Only gradually could the population move outward. That creates an interesting possibility. The generation ship might never truly stop being a home. Instead, it could become the first city of a new world. The descendants could live inside it while building settlements around it. The ship that carried them across the stars could become the historical center of their new civilization. Its original engines might eventually shut down. Its agricultural systems might be dismantled. Its corridors might become museums. Children born generations later could walk through the old habitat and look at the walls their ancestors once lived behind. They would see records of Earth, photographs, maps, the original launch plans, perhaps a clock showing the date the ship departed, and perhaps for the first time they would understand that their entire world began as a machine. But before that can happen, the ship has to survive the most dangerous stage, the early journey, the first decades. Because at launch, everything is new. The systems have not yet aged. The crew has not yet accumulated generations of experience. The population is small. The mission is still psychologically connected to Earth. Communication may still be possible. The original engineers may still be alive. If something goes wrong, there may be a chance to understand it. But as the decades pass, that connection weakens. Communication delays increase with distance. Eventually, a conversation with Earth would take years, then longer. A message sent from the ship would arrive after the people who wrote it had changed their lives. Eventually, Earth might send a response that belongs to another era. The ship's society would become increasingly autonomous. And then one day, the crew might realize that Earth is no longer a partner. It is a distant ancestor. The transition would happen quietly. No alarm, no dramatic moment, just distance, more and more distance, until the ship's civilization is alone. That may be the moment the generation ship truly becomes a new planet, because planets do not receive instructions from their creators. They simply exist. The people on board would have to make decisions for themselves, and those decisions could determine whether the ship survives. A planet can survive a political crisis because the physical world remains. A generation ship cannot separate society from infrastructure so easily. Human conflict can damage the habitat. That makes governance one of the ship's most critical life support systems. There would have to be rules, but rules alone are not enough. There would need to be institutions, courts, medical ethics, education, emergency authority, resource management, perhaps democratic structures, perhaps carefully designed forms of representation. The exact system is impossible to know, but one principle seems unavoidable. No single person can safely control everything. The consequences of abuse would be too large. If one leader controls food, water, oxygen, power and security, political disagreement could become existential. The ship would need distributed authority, but distributed authority also creates coordination problems. Emergency situations sometimes require immediate action. A fire does not wait for a committee. A hull breach does not wait for a vote. So the civilization would need emergency procedures, temporary authority, clear thresholds, checks on power, and systems for returning authority to ordinary governance afterward. These are problems humanity already wrestles with on Earth. A generation ship would simply make them impossible to ignore. And perhaps that is one of the hidden purposes of building such a spacecraft. It would force humanity to confront the weaknesses of civilization itself. We often imagine that the hardest part of becoming interstellar is building the engine, but perhaps the engine is only one piece. The harder question is whether a human society can remain stable when it has nowhere else to go. Earth has always offered escape routes, migration, exploration, new cities, new continents. A generation ship would eliminate most of them. The society would have to learn how to solve conflicts without physically separating. That could be one of its greatest achievements. If humanity ever succeeds in sending generations toward another star, the technology may be impressive, but the civilization that survives the journey may be the real breakthrough. A machine can be designed. A society has to be continuously rebuilt. Every generation, every child, every teacher, every repair, every decision. And while all of this is happening, the ship keeps moving. The stars ahead do not care. The universe does not slow down because a pump failed. A solar storm does not care about political disagreements. A microscopic leak does not care who is in charge. The physical world remains indifferent, which means the people inside the ship must become extraordinarily good at cooperation. Not perfect, just good enough, again and again, for centuries, because the ship has one final requirement. It cannot simply carry the future. It must make the future possible. And that means the people living inside it cannot spend their entire lives waiting for arrival. They need to build lives worth passing on. Children need reasons to dream. Adults need reasons to work. Old people need reasons to believe their experience matters. The ship needs birthdays, music, friendships, arguments, reconciliation, stories, laughter, grief, everything that makes a civilization more than a survival mechanism. Otherwise, the spacecraft may reach the stars with its systems intact and its humanity diminished. The goal was never merely to arrive alive. The goal was to arrive human. And perhaps that is why the most important component aboard the ship would not be the engine, not the reactor, not the agricultural system, not the radiation shield. It would be the invisible thing connecting one generation to the next. The belief that the people who come after you matter. That idea could keep the lights on long after the original crew is gone. It could convince someone to repair a machine they will never personally need, to plant a tree whose shade they will never sit beneath, to teach a child a skill that may not become useful for decades, to preserve a language they may never hear spoken on another world. The ship would move forward because people kept preparing the way for strangers who were actually their descendants. And somewhere far ahead, hidden among the stars, would be a world they had never seen. Perhaps it would be beautiful. Perhaps it would be hostile. Perhaps it would already contain conditions no one predicted. But for the people aboard the ship, the destination would have one enormous advantage over Earth. It would be waiting. And eventually, after generations of darkness, the first descendants of the original crew might look through the forward windows and see something no one aboard has seen before. Not another star, not a distant point of light, but a world, a planet, large enough to become real, close enough to see. The ship would still be moving, the habitat would still be humming, the farms would still be growing, the people would still be breathing recycled air. But for the first time, the artificial world they had inherited would have another world waiting outside it. And that would be the moment when the journey changes again. Because surviving the voyage was only half the problem. Now they would have to decide how to leave the ship. For generations, the people aboard the ship had looked at the stars as destinations. Now, one of those stars would finally begin to look different. It would no longer be just a point of light. It would have a location, a system, a future, and perhaps somewhere within that system, a planet. The first reaction might not be celebration, it might be disbelief, because the human mind is built to understand distance through experience. We understand a kilometer because we can walk it. We understand a mountain because we can see it. We understand an ocean because we can stand beside it. But an interstellar destination is different. For hundreds of years, it would exist only as information, coordinates, images, spectral measurements, numbers stored in computers. Then slowly it would become visible, a small object growing brighter against the darkness. The descendants aboard the ship would know exactly what it means. They are getting close. But close is relative. Even after centuries of travel, the final approach could still be dangerous. The ship would have enormous momentum. It would need to slow down. The target system would contain planets, moons, asteroids, dust, radiation, and a star whose activity might be very different from what the original mission planners expected. The ship would have to navigate all of it. And there would be another problem. The target planet might not be habitable. That possibility would have been considered from the beginning, but observations made centuries earlier may not tell the whole story. Astronomers could identify a planet's size and orbit. They could estimate its temperature. They could study its atmosphere from afar. But remote observations have limits. The actual environment could be much more complicated. A planet might sit in the so-called habitable zone and still be hostile to humans. The habitable zone simply refers to a region around a star where temperatures could allow liquid water on a planet's surface under suitable atmospheric conditions. It does not mean the planet is safe. Venus is a perfect warning. It is relatively close to Earth in size and composition, yet its surface is extraordinarily hostile. Its atmosphere is dominated by carbon dioxide. Its surface pressure is immense. Its temperatures are hot enough to melt lead. Being in a favorable orbital region is not enough. The destination would need to be understood, and that means the ship might spend years in the target system before anyone steps onto the planet. Robotic probes could be sent ahead. Small craft could survey the atmosphere. Sensors could measure radiation. Samples might be collected. The civilization would finally have something it had never possessed during the journey: an outside world. But the ship would still be the safest place. So perhaps the first settlement would not begin on the surface. It might begin in orbit. The generation ship itself could become the initial orbital habitat. Smaller spacecraft could explore the planet. Factories could be established around asteroids or moons. Resources could be extracted from nearby bodies. Slowly, the new system would become familiar. And this is where the original concept of a generation ship begins to transform again. The ship was built to cross space, but once it arrives, it becomes infrastructure. Its role changes. It becomes a foundation. The descendants no longer need to remain entirely dependent on it. They can begin creating new systems around it. That could be the first time the artificial world begins to reproduce itself. Not biologically, civilizationally. One habitat becomes two. Two become 10. Factories produce new structures. Resources come from asteroids. Solar power becomes available throughout the system. New habitats are built, and the original ship becomes one part of a growing settlement. The descendants would finally be doing something their ancestors could only imagine. They would be building a civilization around another star. But perhaps the most emotional moment would come much earlier. The first person to see the destination planet with their own eyes. Imagine standing inside the observation section. The lights are dim. The spacecraft is still moving. Around you are people who were born aboard the ship. Some have spent their entire lives studying the destination. Some have trained for the arrival. Some have never known another world. And then the planet appears. Not as a number, not as a simulation. A real sphere, floating in darkness, with sunlight falling across its surface. Clouds, perhaps oceans, perhaps continents, perhaps colors that look strangely familiar. For a moment, the entire history of the mission would collapse into one image. Earth would be behind them. This world would be ahead. And between them lies everything their ancestors sacrificed. Every generation that maintained the farms. Every engineer who repaired machinery. Every teacher who preserved knowledge. Every parent who raised children inside a moving habitat. Every person who died without seeing the destination. All of them would somehow be present in that moment, not physically, but through continuity, and that is the emotional core of the generation ship. The first settlers would not simply arrive somewhere, they would inherit something. A promise made by people who would never see its fulfillment, but the planet might still refuse them. Suppose its atmosphere contains toxic gases. Suppose the surface pressure is too high. Suppose the temperature is outside the human comfort range. Suppose water exists, but only as ice or underground deposits. Then the descendants face a choice. They can remain aboard the ship, or they can begin transforming the environment. Terraforming is often discussed as though it were a straightforward engineering project. It is not. Transforming an entire planet's climate would require enormous quantities of energy and matter. Depending on the world, It could require changing the atmospheric composition, pressure, temperature, and availability of water. And those changes might take centuries or much longer. The planet could remain hostile for generations, so the first settlers might build enclosed habitats instead. Domes, underground cities, pressurized structures, artificial ecosystems. In other words, they might reproduce the generation ship on the surface. The irony would be almost perfect. Humanity travels across the stars searching for a new world. It arrives, and then builds another artificial world because the natural planet is not yet suitable. That could happen. Perhaps the ship would become the first habitat network. Its descendants would slowly expand. The original vessel might be dismantled for materials. Its shielding could become construction material. Its metal could become buildings. Its reactors could power industry. Its agricultural systems could be transplanted. Piece by piece, the ship could disappear into the new civilization. The machine that carried humanity between stars would literally become part of the planet's settlement. And perhaps one day, thousands of years after the original launch, almost nothing of the spacecraft would remain, except a memorial, a museum, a plaque, a single section preserved beneath a city. It might contain the original launch date, the names of the first crew, an image of Earth, and perhaps a sentence explaining why they left. That would be a strange ending. The ship would have fulfilled its mission by becoming unnecessary, like scaffolding around a building. It existed so something else could be built. But there is another possibility. The planet could be perfectly habitable, and even then, leaving the ship might not be easy. After generations, the habitat would be familiar. The planet would be unknown. The ship has artificial gravity, controlled temperature, predictable air, protected agriculture, reliable walls. Outside is uncertainty. Even if the atmosphere is safe, the surface would contain unfamiliar microorganisms, unfamiliar terrain, and unfamiliar weather. A person born aboard the ship might be afraid to step onto a natural planet. Think about what that means. For us, standing outside is normal. For them, it could be the strangest experience imaginable. The wind would be real. The sky would be enormous. The ground might extend beyond anything they have ever seen. Clouds would move without a schedule. Rain would fall without passing through a filtration system first. Sunlight would come directly from the star, and there would be no ceiling. That might be overwhelming. Perhaps the first settlers would step outside wearing protective equipment. They would touch the ground, and for the first time in generations, human feet would stand on a natural world outside Earth. The psychological impact could be profound. Some might cry, some might laugh, some might feel nothing, because not everyone responds to history in the same way, and that matters. A generation ship would not produce a single kind of human being. It would produce generations of individuals. Some would love the ship, some would hate it, some would dream about the planet, some would prefer never to leave. The arrival would therefore not be the end of the story. It would create another cultural conflict. Who wants to leave? Who wants to stay? Who gets to decide? Perhaps the ship would remain inhabited by people who prefer the controlled environment. Others would settle on the planet. Some might move between both. The civilizations could split, and after centuries of traveling together, humanity could finally become two populations again. One living in artificial habitats, another living on the planet. That separation could produce new cultures, new identities, new political systems. The generation ship would have carried humanity across one of the greatest distances imaginable. But the journey could ultimately create the same phenomenon that happened repeatedly on Earth: migration, settlement, cultural divergence, new societies. The difference would be that this time, the migration crossed another star. And perhaps that is what makes the idea so powerful. It does not require science fiction physics. It does not require faster than light travel. It does not require magical technology. It requires something much harder: patience, engineering, stability, and an almost unimaginable commitment to people who do not yet exist. The first generation would have to accept that they are not going. Their children might not go either. The people who arrive could be hundreds of years removed from the original crew. That means the mission is an act of trust across time. You build something knowing that someone else will use it. You maintain something knowing someone else will inherit it. You leave your home knowing that the people who arrive may never understand how difficult the journey was. That is an unusual form of sacrifice. It is not sacrifice for a country, not for fame, not even necessarily for yourself. It is sacrifice for descendants you have never met. And in that sense, the generation ship may represent one of the oldest human instincts in an entirely new form. Parents build for children. Civilizations build for future generations. Farmers plant trees they may never see mature. Engineers design bridges that outlive them. Scientists record knowledge for people centuries ahead. The generation ship simply extends that instinct across the stars. But there is still one question hanging over everything. Why? Why leave Earth at all? The honest answer is not that Earth is about to become uninhabitable. We have no scientific reason to assume humanity must abandon Earth in the near future. Earth remains extraordinarily valuable and uniquely suitable for human life, and any serious effort to become interstellar would not replace the responsibility to protect our home planet. The generation ship would be a supplement to civilization, not an excuse to destroy the place that already supports us. So the motivation would have to be larger: curiosity, long-term survival, exploration, the desire to become a species that exists on more than one world, and perhaps something deeper. The universe is vast. Human civilization exists on one planet around one star. That is an incredibly narrow footprint. If something catastrophic happened to Earth, every human being would be affected. A civilization distributed across multiple worlds would be more resilient, not invulnerable. Nothing is, but less dependent on a single planetary environment. A generation ship could therefore be seen as an extension of civilization's survival strategy, not because Earth is disposable, because Earth is precious, and the more places humanity can safely live, the less likely the entire species is to disappear because of one catastrophe. But that future is not guaranteed. There are enormous technological barriers. We do not currently possess the propulsion systems, industrial infrastructure, life support systems, or closed ecosystems needed for a true generation ship. Even building a self-sufficient habitat in Earth orbit would be an enormous challenge. Building one capable of surviving for centuries while traveling between stars is beyond current engineering. That is important to say clearly. The concept is physically motivated. The implementation is speculative. We know many of the problems. We do not yet know whether we can solve all of them, and some problems may require technologies that do not exist today. That uncertainty is not a reason to stop thinking about the idea. It is the reason to study the problems carefully, because every serious generation ship concept reveals something about civilization. How much energy do we need? How much food? How much land? How much redundancy? How many people? How much knowledge? How much trust? How much time? Those questions are useful even if humanity never launches such a ship. They force us to think about what survival actually requires, and they reveal how much Earth's natural systems do for us without asking permission. The atmosphere is a planetary life support system. The oceans are enormous thermal and chemical reservoirs. The biosphere recycles matter. Gravity holds everything together. The magnetic field helps shield the planet from charged particles. Sunlight provides energy. The entire system works continuously. We inherited it. We did not build it. A generation ship would have to imitate a tiny fraction of that complexity deliberately. That comparison changes the way you look at Earth. From space, our planet can look simple, a blue sphere, but inside that sphere is an unimaginably complicated network of systems. A generation ship would reveal the hidden complexity of home by forcing humans to recreate it. Every breath would become engineering. Every meal would become agriculture. Every glass of water would become chemistry. Every forest would become infrastructure. Every season would become software and lighting. Every medical treatment would depend on stored knowledge. And every human relationship would exist inside a habitat where there is no outside. That is why the spaceship has to become our new planet. Not because we want to imitate a planet for the sake of aesthetics. Because if the journey lasts long enough, the ship has to perform many of the functions Earth performs naturally. It has to become the environment. And the longer the voyage lasts, the more complete that environment must become. A short mission can survive with supplies. A long mission needs recycling. A multi-generational mission needs agriculture. A centuries-long civilization needs manufacturing. A truly independent world needs culture. And eventually, perhaps, it needs a new generation willing to look at the unknown and say, we can build here. But there is one final layer. The ship itself may be temporary. The planet may be temporary. Even the star may eventually change. Nothing in the universe is permanent. Stars are born. Stars age. Galaxies evolve. Planets form and disappear. Civilizations rise. The generation ship is therefore not a machine for escaping mortality. It is a machine for extending continuity. That distinction matters. The people who build it will still die. The people who launch it will still die. The people who arrive will eventually die. What continues is the chain. One generation handing the world to another. One set of hands repairing what another set built. One child learning from an elder. One civilization becoming the ancestor of another. And somewhere in that chain, if everything works, someone will stand beneath a natural sky around another star. They will look upward. They may not remember the name of the original engineer who designed the ship's water system. They may not know the people who repaired its engines 200 years into the journey. They may never have seen Earth, but they will be there because those people continued, because the ship continued, because the civilization continued. And perhaps that is the closest humanity can come to carrying a planet with us, not literally, but through everything a planet gives us: air, water, food, shelter, memory, and a place where the next generation can begin. There is one final problem waiting for the people who arrive at another star. They have spent centuries learning how to live without a planet. Now they have to learn how to live with one again. That sounds easy. It is not. A natural planet does not come with instructions. Its weather changes. Its terrain is unpredictable. Its atmosphere may contain surprises. Its oceans may hide resources or dangers. Its biology, if any exists, would be completely unfamiliar. And unlike the controlled interior of the ship, the planet would not care whether humans were ready. The first explorers would have to approach it cautiously. Robotic probes would likely come first. They could map the surface, measure atmospheric composition, search for water, study temperature, analyze radiation, look for chemical signatures that might indicate biological activity. Every discovery would answer one question and create another. If water exists, where is it? If oxygen exists, how much? If the atmosphere contains carbon dioxide, how dense is it? If there are clouds, what are they made of? If there is life, what kind? The possibility of extraterrestrial life would make the situation even more complicated. If the planet already contains biology, humans would have to consider whether entering that ecosystem could damage it. And if organisms exist, the question of contamination would become enormous. Humans have experience introducing species into environments where they do not belong. The results can be devastating. A generation ship arriving at another world would need to be extremely careful. The first contact with an alien ecosystem, if one exists, would not be a casual walk through a new forest. It would be a scientific event, perhaps the most important biological event in human history. For the descendants aboard the ship, however, there would be another concern. The planet might be physically habitable, but psychologically overwhelming. For someone raised inside a habitat, an open landscape could feel dangerous. The sky would have no ceiling. The horizon would disappear into distance. The ground could stretch for kilometers. Wind would move through the environment without passing through ducts. Rain would fall unpredictably. The first humans who lived on Earth never had to learn how to appreciate open space. It was simply there. The descendants of a generation ship might need to learn it. They would have to adapt not just technologically, but culturally. Children born on the new planet would have an entirely different relationship with nature. For them, the ship might become the strange place, a historical artifact, a cramped metal world where their ancestors lived before they had a real sky, and this creates a fascinating reversal. The original crew would have looked at Earth and thought of it as home. Their descendants might look at the planet they reached and think of it as home. The ship would become the old world. The new planet would become the future. But Earth would remain in the background of their identity. A civilization can carry its origin long after leaving its birthplace. Languages preserve old words. Cultures preserve old rituals. Buildings preserve old architectural patterns. Stories preserve old memories. The new civilization might do the same. Perhaps the names of cities on the new planet would come from Earth. Perhaps continents or valleys would be named after places no living person had ever visited. Perhaps an ocean would be named after the Pacific. Perhaps a mountain would carry the name of a place on Earth. Not because anyone expects to return, because humans tend to carry the past into the future. And the generation ship itself would become one of the greatest symbols of that history. It would represent the age when humanity lived between planets, a time when the species had one foot on Earth and one in the darkness, a time when survival depended on a machine. But even if the new world becomes home, the ship's story would not be over. Its descendants might continue exploring. Other stars would remain, other planets, other habitats, and eventually another generation ship could be built, perhaps much larger, perhaps more advanced, perhaps using knowledge gained from the first journey. The first ship would become a prototype. The second civilization would not need to repeat every mistake. That is how exploration usually works. The first attempt reveals the problems. The next attempt solves some of them. The following attempt solves more. Over time, what once seemed impossible becomes routine. The first powered flight was fragile. Modern aviation is not. The first computers filled rooms. Now tiny devices contain more processing capability than early machines could provide. The first spacecraft were primitive compared with today's probes. But interstellar travel presents a unique problem. The distance is so enormous that technological progress on Earth might happen faster than a ship could travel. Imagine launching a spacecraft toward another star. 100 years into the voyage, technology on Earth has improved dramatically. The ship cannot upgrade itself from Earth unless it carries the ability to do so. The descendants on board might therefore find themselves living with technology that is centuries old while Earth continues advancing. This creates another reason for the ship to be adaptable. If the spacecraft cannot change, it risks becoming obsolete. Perhaps the descendants could receive information from Earth for much of the journey, but eventually, communication delay would become enormous. At 4 light years, a message takes more than 4 years to travel one way. A question sent to Earth would require years before a response could arrive. For a civilization living inside the ship, that is not conversation. It is correspondence across generations. Eventually, the ship may become technologically independent. Earth might continue to exist, but the ship's civilization would no longer be part of Earth's daily world. It would become its own branch of humanity. And that is where the concept becomes both exciting and unsettling. The people aboard may eventually become culturally different enough that if they could meet Earth again, the two populations might feel like distant relatives. Same species, shared ancestry, different histories, different environments, different technologies, different societies. The journey would have changed them, not necessarily biologically at first, but culturally, and perhaps eventually biologically too. If generations live under artificial gravity different from Earth's, if their diets differ, if medical technology alter reproduction or aging, If the population remains isolated for long enough, evolutionary and genetic effects could accumulate. This is not something we can predict precisely. Human evolution operates over many generations and depends on selection, mutation drift, population size, and environment, but isolation matters. A population separated for centuries or millennia can diverge. The generation ship would therefore be carrying more than a civilization. It could be carrying the beginning of a new human branch, not necessarily a new species, but a population with its own history, its own adaptations, its own identity, and that possibility makes the phrase new planet even more meaningful, because the planet would not simply be a new place to live, it could become the birthplace of a new chapter in human evolution. Yet the ship's great legacy might be much simpler. It might teach humanity how to build closed systems that actually work. That knowledge could transform life long before the first interstellar voyage. Large orbital habitats could provide homes for people away from Earth. Closed-loop agriculture could reduce waste. Advanced recycling could conserve resources. Artificial ecosystems could support long-duration missions. Space manufacturing could expand. Nuclear power could improve. Robotics could become more capable. The technology required for a generation ship would have applications throughout the solar system. So even if humanity never launches one, working toward the capability could still change civilization. The first steps might happen much closer to home, on the Moon, on Mars, in orbital habitats, around asteroids. Each settlement would teach us more about independence from Earth, how to produce food away from Earth's biosphere, how to recycle almost everything, how to manufacture without terrestrial supply chains, how to maintain communities in hostile environments, how to live with limited resources. Every step would reduce the distance between a spacecraft and a planet, because the ultimate goal is not really the ship. The goal is a civilization capable of living beyond Earth. The ship is simply one possible bridge, and bridges are designed to be crossed. Eventually, the civilization may not need generation ships at all. If propulsion improves dramatically, journeys could become shorter. If humans develop reliable suspended animation technologies, which do not currently exist for long-term human spaceflight, that could change the equation. If propulsion approaches a significant fraction of light speed, travel times could become manageable on human scales, although the energy and engineering challenges would remain enormous. But none of these possibilities should be confused with current capability. Today, we do not have a generation ship. We do not have a proven method for sending humans to another star. We do not have a closed ecosystem capable of supporting a human civilization indefinitely. We do not have a practical faster-than-light drive. The distance between imagination and engineering remains enormous. And perhaps that is exactly why the idea is worth examining carefully. Because the hardest part of the journey is not the fantasy. It is the boring reality. Pumps, filters, bearings, valves, seeds, waste, training, power, maintenance, redundancy. Those are the things that determine whether a civilization survives. Not the dramatic launch, not the beautiful concept art, the ordinary systems. The systems nobody notices until they stop working. A generation ship would be an enormous machine built around the principle that ordinary things must continue working for an extraordinary amount of time. That may be the most difficult engineering challenge humanity has ever attempted. And there is another reason the challenge is so profound. The ship would have to survive people. Machines fail in predictable ways. People do not. A human being can make a mistake, but humans can also improvise. They can notice something the sensors missed. They can invent a repair. They can adapt to a new problem. They can teach one another. The same species that creates risk also creates resilience. That may be the ship's greatest advantage. It would not be fully automated. It could not be. For a journey lasting centuries, automation would have to be extensive, but human judgment would remain essential. The descendants would become part of the maintenance system. not because they are tools, because they are the only part of the ship capable of understanding circumstances the original designers never imagined. And circumstances will change. A component may fail in an unexpected way, a crop may behave differently, a disease may appear, a manufacturing process may become inefficient, a new technology may be discovered. The civilization must be able to respond. This is why the best generation ship would probably not be the one with the most complicated systems. It might be the one that gives its descendants the greatest ability to adapt. That is a profound design philosophy. Build something that can survive being changed. A ship that cannot change may be impressive. A ship that can evolve may actually survive. And perhaps this is where the spacecraft finally becomes more like Earth. Earth is not a static machine. It changes continuously. Life adapts, climates shift, species appear and disappear, landscapes transform. The planet survives partly because life can respond. A generation ship would need a similar flexibility. Its people would become part of its adaptive system. Their knowledge, their creativity, their culture, their ability to solve problems. The ship would not survive despite its human passengers. It would survive because of them. But humans are also vulnerable. One of the biggest risks on a multi-generational voyage could be psychological isolation. People need social networks, need purpose. They need meaningful relationships. If the population becomes too small, social dynamics could become unhealthy. If it becomes too large, resource demands could become unsustainable. If society becomes too controlled, rebellion could threaten stability. If society becomes too fragmented, cooperation could collapse. There is no perfect population structure, no perfect government, no perfect culture. The ship would have to continuously negotiate between competing needs, freedom and safety, individual choice and collective survival, tradition and adaptation, efficiency and quality of life, privacy and transparency. The original crew could try to design solutions. Their descendants would inevitably change them, and perhaps they should. A society that survives for centuries cannot be frozen at the moment of launch. The mission must be stable enough to continue, but flexible enough to evolve. That balance may be more important than any single technological breakthrough, because the ship's greatest enemy is not distance. It is brittleness. A brittle system works perfectly until it does not. A resilient system can absorb damage, it can bend, it can adapt, it can recover. Earth is resilient because it contains redundancy on an enormous scale. If one organism dies, others remain. If one forest burns, another may exist elsewhere. If one species disappears, the ecosystem may reorganize. A generation ship would need to create its own forms of redundancy. Multiple farms, multiple energy sources, multiple manufacturing pathways, multiple experts, multiple archives, multiple habitats, perhaps even multiple independent communities. The goal would be to ensure that one failure does not become total failure. This is the difference between a spacecraft and a civilization. A spacecraft can be designed around mission success. A civilization must be designed around recovery. And if the journey is long enough, recovery will be necessary. There will be accidents. There will be disagreements. There will be deaths. There will be equipment losses. There will be periods when the original plan no longer fits reality. The ship must continue anyway. That is why the final measure of success is not whether the spacecraft reaches the destination exactly as designed. It is whether the people reach the destination at all. Perhaps the ship will look different. Perhaps half its original systems will have been replaced. Perhaps its population will be larger or smaller than expected. Perhaps its culture will be unrecognizable. Perhaps the original mission plan will have been rewritten many times. None of that necessarily means failure. If the civilization survives, adapts and arrives, the mission succeeded. That is a very different definition of engineering. The original builders are not the final judges, the descendants are. And eventually, the descendants may stand on the surface of another world and look back at the spacecraft. They might see a structure that has traveled farther than any human-made object before it. A machine that survived centuries of radiation, impacts, aging, political change, ecological problems, and generations of human life. And perhaps someone will ask, was it worth it? There will be no universal answer. Some people may say yes, others may say Earth was enough. Others may say the journey was the greatest mistake humanity ever made. All could be sincere, but one fact would remain. They made it. They survived. They became something their ancestors could only imagine, a species living beneath another star. And perhaps that is when the meaning of home changes one final time. Home is no longer the place you came from. Home is the place where your children can safely grow. For the original crew, that was Earth. For the first generations, it was the ship. For their descendants, it could become the new planet. 3 different homes. One continuous human story. And if that story continues long enough, the new planet may eventually produce people who look at the old ship the way we look at ancient ships on Earth. A relic, a vessel that once carried people across an impossible distance. They might walk through its corridors and struggle to imagine that their ancestors spent centuries inside them. They might see the old agricultural chambers, the original control systems, the preserved image of Earth, and perhaps they will realize something that the first crew could never have known. The ship was never supposed to last forever. It only had to last long enough for the next generation, then the next, then the next. And perhaps that is the strangest thing about a journey between stars. The people who begin it may never experience the destination. They may spend their entire lives inside the ship, knowing that another generation will see what they never could. Their reward is not arrival, it is continuation. A parent repairs a system so a child can breathe. An engineer preserves knowledge so a stranger born 200 years later can use it. A farmer saves seeds for crops that will feed people who have never been born. A teacher passes on skills to students who may eventually become the ancestors of an entire population on another world. The ship moves forward because people keep preparing the future for people they will never meet. That is a very old human idea, but taken across interstellar space, it becomes almost incomprehensible in scale. On Earth, we build for the next generation. On a generation ship, we would build for the 100th generation. The difference is not simply time, it is responsibility. Every decision would stretch farther into the future. A careless choice could become a problem decades later. A wise choice could become invisible. The people who benefit from it might never know who made it. And perhaps that is what makes the generation ship such a powerful symbol. It is a machine designed around the assumption that the future matters. Not as an abstract idea, as a physical reality. The future needs air. The future needs water. The future needs food. The future needs knowledge. The future needs functioning machines. The future needs people willing to maintain what they inherited. And eventually, the future needs somewhere to go. That is why the ship cannot simply be a giant capsule. It has to become an ecosystem, then an economy, then a society, then a culture, and finally a world. A world without mountains may still need places where people can escape. A world without oceans may still need water. A world without natural seasons may still need rhythms. A world without an open atmosphere may still need beauty. A world without Earth may still need memory. The ship would have to provide all of these things in its own way. And perhaps that is why the most important resource aboard would not be water, oxygen, or energy. It would be time. Time for systems to improve. Time for children to learn. Time for cultures to evolve. Time for mistakes to be corrected. Time for the destination to approach. Time for humanity to become something larger than a civilization tied to one planet. The universe does not demand that we hurry. The stars are not going anywhere in the human sense of time. If interstellar civilization ever becomes possible, it may begin slowly. One star, one habitat, one generation, one ship, and then another. The first journey could take centuries. The second might be faster. The third might be larger. The fourth might carry technologies the first crew could not imagine. but every future journey would depend on the lessons of the first. That is how exploration works. The unknown becomes known one careful step at a time. And perhaps the first generation ship would not be the elegant spacecraft imagined in futuristic illustrations. It might be enormous, ugly, industrial, covered in shielding, filled with tanks, farms, machinery, storage compartments, workshops, cables, pipes, radiators, and redundant systems. It might not look like a sleek spaceship. It might look more like a moving factory. And that would be appropriate, because the ship's purpose would not be beauty. Its purpose would be continuity. It would be a machine whose most important achievement was making ordinary life possible in an extraordinary place. Someone wakes up, they eat breakfast, they go to work, a child goes to school, a technician checks a pump, a farmer examines a crop, a doctor treats a patient, someone plays music, someone falls in love, someone argues, someone laughs, someone grows old, and outside all of them is the darkness between stars. That contrast might become one of the strangest parts of the human experience. Inside, life continues almost normally. Outside, there is almost nothing. No air, no sound, no ocean, no familiar world, only stars. The ship would make the universe feel enormous while simultaneously making daily life feel very small. And perhaps that is something humanity would need to learn. We do not need to conquer space. We need to learn how to live within it. The first generation ship would not defeat the universe. It would simply create a small pocket of life inside it. A fragile island moving through darkness. And if that island survives, it would prove something extraordinary. Not that humans are invincible. We are not. Not that technology can solve every problem. It cannot. But that life can carry itself farther than its original environment. Earth created life. Life created intelligence. Intelligence created machines. And perhaps one day, those machines will carry life to another star. The sequence is almost poetic. A planet gives rise to a species. The species learns to leave the planet. Then, to survive the distance between stars, it has to carry the functions of the planet with it. Air, water, food, energy, shelter, memory. The spaceship becomes a small artificial echo of Earth. And somewhere inside that echo, children are born. Children who have never touched Earth's soil. Children who may never see Earth's ocean. Children who know the word Earth because someone taught it to them. For them, Earth is not home, it is origin. And that distinction may be the deepest transformation of all. Humanity's first home would become its first ancestor. The ship would become the bridge. The new planet would become the future. And perhaps, thousands of years later, another civilization will stand on that world and ask the same question we are asking now. Where did we come from? They may find records. They may discover the names of the first crew. They may see images of a blue planet. They may read about a civilization that once lived around a star called the Sun. They may learn that their ancestors crossed more than 4 light years of space inside a machine that had to become a world. And perhaps they will be amazed that anyone believed it was possible. But the answer would be simple. Someone had to try. Someone had to build the first bridge. Someone had to accept that the journey might outlive them. And someone had to believe that a person not yet born was worth preparing the future for. That may be the most human part of the entire story. Not the engines, not the mathematics, not the radiation shielding, not the artificial gravity. The decision to build something you will never personally use. That is civilization. Every generation receives a world it did not create. Then it decides what to do with it. A generation ship would make that responsibility impossible to ignore. There would be no illusion that resources are infinite. No illusion that maintenance happens automatically. No illusion that the future will take care of itself. The future would be inside the walls. It would depend on what people do today. And perhaps that is why imagining such a ship changes how we look at Earth. Because Earth already does everything the spaceship would struggle to imitate. It produces oxygen. It recycles water. It grows food. It regulates temperature. It provides gravity. It protects us from much of the space environment. It contains enormous biological diversity. It absorbs waste, it stores energy, and it does all of this without asking us to operate a control panel. We were born into a planetary life support system so vast that we mistake it for background. Only when we imagine leaving it do we begin to notice what it provides. A breath is not simple. A glass of water is not simple. A meal is not simple. A stable climate is not simple. A forest is not simple. Earth is not a passive stage beneath human civilization. It is part of the machinery that makes civilization possible. A generation ship would reveal that truth with brutal clarity. Inside it, nothing could be taken for granted. Every system would have a name. Every failure would have consequences. Every resource would have a cost. And perhaps the descendants who finally reached another world would understand something their ancestors had slowly forgotten. A planet is not just a place to stand. It is a system that keeps you alive. The spaceship would have spent centuries trying to become one, and when the new world finally became home, the ship would have completed its strange transformation. It would have begun as a vehicle, then become a habitat, then a society, then a civilization, and finally perhaps an ancestor. Its engines could shut down, its systems could be dismantled, its corridors could become historical sites, but the people would continue. That is the real measure of success, not whether the ship remains intact, whether the story continues beyond it. So imagine that final scene. The descendants are standing beneath another star. Above them is a sky that no human ancestor had ever seen. Perhaps the planet has clouds, perhaps there are oceans, perhaps there are mountains, perhaps it is nothing like Earth, but there is ground beneath their feet, real ground, natural gravity, a natural horizon. The wind moves around them, and somewhere behind them, perhaps still visible in orbit, is the ship, the old world, the machine that carried their ancestors across the darkness. They look back at it, and for the first time, the spaceship does not feel like home. It feels like history, but it was history that made this moment possible. A few generations ago, their ancestors had looked at the same stars and wondered whether humanity could ever cross the distance between them. They did not know. They could only build. They built the farms. They built the reactors. They built the shielding. They built the workshops. They built the habitats. They built the knowledge systems. They built the culture. And then they left. They trusted people they would never meet. Those people trusted the next generation and the next, until eventually someone stepped onto another world. No single person accomplished it. No single generation did it. It was a chain, and that chain is perhaps the only way humanity could ever cross distances this large. Not by making one human life long enough, by making civilization continuous enough. The stars are too far away for one lifetime, but perhaps they are not too far away for humanity. That is the quiet possibility. We do not need to outrun time. We may only need to learn how to pass the future forward, from one generation to another, from one world to another, from one star to another. And if that ever happens, the first interstellar spaceship will not simply be remembered as a spacecraft. It will be remembered as the place where humanity learned how to carry a world with it. A world made of air and water, of machines and plants, of knowledge and memory, of children who inherited a journey they never chose, and of people who were willing to begin something they knew they would never finish. The ship would leave Earth. Earth would become smaller behind it. The stars would remain impossibly distant, but the civilization inside would continue. One breath, one repair, one harvest, one child, one generation, then another and another, until the darkness between stars was no longer an ending. It was simply the road, and somewhere beyond that road, another world waited. Not a replacement for Earth, not a perfect paradise, just another place where human life might begin again. So tonight, as you imagine the stars outside your own window, remember what they really represent. Not merely distance, not merely darkness, but possibility. Because the universe may be vast beyond anything the human mind can comfortably understand, And yet, every civilization begins somewhere small. A planet, a habitat, a ship, a handful of people deciding that the future is worth preparing for. Perhaps that is how humanity eventually reaches the stars. Not all at once, not by escaping Earth, but by carrying its most important gift forward, life. And perhaps one day, when another generation looks back at the blue world around the distant sun, they will understand that the greatest spacecraft humanity ever built was never designed merely to travel. It was designed to become home, and for as long as the people inside it kept caring for one another, it did. The engines carried the ship forward, the machines kept it alive, the farms fed it, the walls protected it, but people gave it meaning, and that is what finally made a spaceship into a planet. A place where life could continue, a place where memories could survive, a place where tomorrow could begin. The stars remain above us, Earth remains beneath us, and somewhere between them lies a future we have not built yet. Maybe we will never build it. Maybe the engineering challenges will prove too great. Maybe another path will take humanity to the stars. But if one day a spacecraft truly does leave Earth carrying generations of people toward another sun, it will carry more than technology. It will carry the oldest human instinct of all, the belief that the next generation deserves a tomorrow. So let the universe remain vast tonight. Let the stars remain distant. We do not have to reach them before morning. For now, it is enough to know that somewhere in that darkness are worlds we have never seen, futures we have never lived, and possibilities that may wait far beyond the limits of one human lifetime. And perhaps that is the quietest lesson of all. We are temporary. The journey can be longer than we are. But a story can continue, a world can be inherited, and sometimes the most important thing we can build is something we will never live long enough to see completed. A ship, a home, a future, a new planet. Good night.